Okay, so um, so I mostly have okay, let's see. This just lets me type. Okay, so I started with C, but I fixed all the broken stuff. You know, C has int, char, unsigned, char, long. Okay, that's a big mess. So the built-in types are U. There's actually a U0. You might ask, why would you need a U0? And there's only F64. So let's say you make a record, a class, student. Let's say you have a linked list. Let's say you have a couple fields. Okay, let's say you're putting this on disk. Well, you don't really want the next pointer to be stored on disk. So what you want to do is you want to say U0 start, and if you wanted to, you could say end, and then you would say mem copy. Let's say destination, source, address source, start, comma. Then I would probably say size of. I always do it size of minus offset source. That's how it. Okay, so that's what that's for. You can set a $sign. You can say $sign equals 128. Presto, that now instant. Let's say you had some crap in here and you wanted it aligned. You wait. You can say $sign equals minus 128, and now you have negative offsets. The x86 architecture, if you have move. Let's say you're doing move RAX 8 off of RBP. Okay, this is a yeah, I don't know, whatever it is, B8 or something like that. C. You start. I don't know what I'm just guessing. Then you have an 08 here. If it goes up to, you can go up to 7F, but look what we've done. We've wasted. What about all the negatives? At this point, it kicks into. Now you have a big number. But what if you want? What if we could use C0? So you can do that if you set this to a negative. That I learned that from Ticketmaster. Maybe it's supposed to be what do you call it? Non-disclosure agreement. I don't know. Anyway, so what I took from C++ is I took the keyword class, and I made so that in regular C you would have to say Am I right? In regular C, you would have to say you'd have to do this. You'd have to say struct student. In my language, it's a class, but there's almost nothing else beyond that. That's from it's merely the word from C++. We don't have a separate. We don't have. There is no struct. Just class. There's union. Union is just like class. You don't say union student. You just say union. Or I'm sorry, you just say student. And I took default arguments from C++. I did not take this. I did not take. There's no object orientedness. I took base classes. There's no. Now, if you hit F1, let's go to my. Want to know why? Do you want to know why I don't like C? Why I don't like C++? I name my variables so that I get built-in classes. So if I say look at this, block device lock. Watch this. I can say find block device lock. And I can find all instances of block device lock. If I were in C++, I could not do that. So mine is a special case. It's a small. When you scale up, it doesn't just get bad; it gets worse. When you scale down, it doesn't just get good; it gets better. So if I do have a small number of names, I should use one namespace and keep it simple, and take advantage of short letters. Make it fit the job. Don't over engineer. If it's a small, use smaller labels. If it's a 100,000 line project that will never grow, look at the Commodore 64 keywords. Anyway, so we do block device lock. Okay, so I took that. I did not take operator overloading. No overloading. I think. No operator overloading. That's good for, there's only a couple cases where that's good. That's good for complex variables, and it's good for matrices. The kids will get carried away with if it's not a known operator, don't fuck with it. That's stupid. That's silly. That's immature. And why the hell did they do this? Is there some reason you couldn't use a comma? When I made my cout, I used to have cout. I just used commas. And then, when I was using commas, I had no problem using bit shifts. You know? No, it's not parsed the same way. It has to be parsed special. I said, fuck it. I have no... There's no C in. That C out is a bunch of crap. What the hell is this fucking shit? Indel, give me a break. That is the most nastiest. It's a nasty ass. And then you want to define all the crap in here and stuff. God, that's awful. How can you live with that? So if you want that's how mine is just a instead of printf, you might have something like that. Mine is just like that. There's none of that legacy crap in there. All of that has been fixed. There's no. What is this god awful shit? You guys are in hell. You guys are in a hellhole, cesspool. How can you live in the cesspool? Anyway, so no operator overload. We have what else about C++? What was the other thing? Exceptions. I have what you do is you put a eight letter. You put an 8-letter string when you do a throw, and then if you want to see what it is when you catch it, fs. I forgot what it is. I think it's exception ch. Anyway, you do not make a class. Why the fuck are you making a class? It's a bunch of crap. So you make this is kind of simplified. So we have a simpler. So there aren't that many exceptions in the operating system. It's 100,000 lines. These are all the exceptions. It's a lot better if you do malloc out of memory exception. So if I say, watch this, I can say U8 star B equals malloc 256, and B returns a value. Okay, B returns a value. If I say now it returns an exception. So the command, shut up, bird. The command line is much better. None of that air no shit. No air no shit. It's all fixed. These are. Shut up, bird. How do I look? Okay. Shut up, bird. So what do we have? What don't we have from C++? So no namespaces. I think I answered it. Now the other question was org mode. Somebody was asking about org mode. You're not really supposed to. Let's say dump. I think this is safe. If you have an area of memory. I don't even know how to do this. Okay, so you can specify. You're not supposed to do. You're not supposed to do position dependent code. All code is position independent. When you compile just in time, it's easy to fix the. You're not supposed to interfere with the management of memory. What are you have when you call the just-in-time compiler, malloc off the code heap. The just-in-time compiler calls mallocs off the code heap. You have no business. Why are you picking an address? You have no business picking an address. There's only two. Compiler kernel is obviously compiled ahead of time, and compiler is compiled ahead of time. You can't compile without a compiler. So these two, that's the bare minimum you need for ahead of time. And you are never supposed to do another module that's ahead of time. So don't even, the kernel, there's an absolute address table that allows position independence. In the startup, there's a place where it goes through the table and patches the absolute addresses. You know, I should probably make that a subroutine just to make it pretty. No reason. Patch absolute addresses. Okay, this goes through the table in the binary file. There's in the flat binary, there's a table at the end for absolute addresses, and it patches all the code. It patches itself. We run ring 0 only, so and all of our code is read, write, execute at all times. We never mark code not executable. We never mark code. It never marks it anything other than we're always ring 0. I think I might have started marking it for ring 3. I have a demo if you really want to play. Our purpose is for you to play with the computer, and if you want to play with ring 3, maybe you get your jollies. I made a demo for that. Anyway, if you go in the lectures, there's a ring 3 demo. I went ahead and even though our operating system is ring 0 only, I made enough to so you don't have to worry about ring 3. That's if you want to do ring 3. That's not used. I should make a big warning about that. Anyway, so the other thing is the compiler module has to be patched, the absolute addresses. You can actually make other modules ahead of time, but you're not supposed to. What you do is you make a project file that looks like this. Then you say compile. Let's go to the compiler. You say compiler. The default is project, I think. That makes a binary file. Then you say load compiler.bin. It's kind of dangerous. I'm gonna reset. Okay, I just rebooted. Anyway, so when you do a load, it's in the kernel. Inside here, it patches the absolute address table. This is a different. It's doing the same thing that we did in assembly code. It's patching the absolute addresses. So as you can see, you have no business. Oh, by the way, my kernel is position independent. I went ahead and oops, kernel start. I went ahead and I made it position independent. You might say that's impossible. No, you just have to do some work. I'm an expert assembly programmer. I deal with little kids who don't even know what the instructions do. So if you call get IP, that pushes the instruction pointer get IP. This normalizes. You have CSIP, code segment instruction pointer. You have to normalize it because obviously it can be it's ambiguous, your code segment instruction pointer. And so this return F is a returns to the next instruction. So basically, if you do a little work, you can make it position independent. If you're an expert programmer, anyway. So there is that that module thing. You can put that in a binary, and I think the loader will load it there. So like for example, you want to make a little binary. I haven't done this in a while. You have to now you have to include headers. As a matter of fact, this is difficult. You have to include stuff. Normally you don't have to include any. Oh, I think I used to have an atom include, or I used to include a. You could include the symbol table. Did I get rid of that? No, it's in. Oh, we should go look at compiler. Okay. Okay. Now you can see that we have a big problem. There's no headers. I burned the bridges. It's no longer friendly for making binary modules. You have to, if you want, you have to include. You have to make a header for everything. There are no headers. So, for example, I think. Okay. Uh-oh. So, character constants. Do you understand the difference? No, you don't. I used to have a compile on my. I used to have a compile on my menu, but obviously that's gone. Compile. I don't know if it's. I think it's CPP. I don't remember. Okay, so we're compiling a binary. Oh, it doesn't even know types. We have to say, there's the internal types. Basically, don't do it. Okay, so now we have binary module. Now, it'll load and execute. Since we had some execute, it'll load and execute. So when we say load, okay, I could talk about the debug. Let's go exit. Import. You can change exports to imports. There's a command that changes export to import. It'll find the .z. It'll find bin. Okay, so this is the world's record for smallest executable file. It's 5D. So dump. We don't use these anymore, so never mind. So what do we have? We have I think we have a 20 byte header on an executable, or I'm sorry, a 32 byte. We have a table of imports and exports. It exports the symbol main. If we say who -r main, it made a module called test, and it exported the symbol main. So we can say main right now. Oh, this is not good. It's not bound to a header. We have to say, if we want, we can make it bound to a header. I think we say extern. Do we? Yeah, extern. extern u0 main. Okay, so it's in memory. You can have multiple I think we're gonna, let's do a so what we have is here is the way the compiler always works is functions are compiled one at a time, immediately, incrementally, and any code outside of a function executes immediately. So we can compile, load, so it all that. I'm wasting my time. The binary files are pretty neat, but they're off limits. Don't do them. I don't. Some people might do them. I don't. There's no reason to do binary files. We want source code. I might be mean and purposely break binary. Just once in a while, I gotta kick the dog. Okay, I don't kick the dog. So let's go to. We are not doing multiple fonts. He wants to know how the font got blue. Let's go to. We are not doing multiple fonts. He wants to know how the font got blue. Let's go to. Okay, so put chars, if you look it up, you give it a 64-bit integer, and it shifts 8 bits at a time and prints 8 bits. So it prints ASCII. So you put a, if you say hello, anyway, it does up to 8-bit characters at a time, put chars. That's just it's efficient. So somebody wants to know how I made my website blue. Well, I started with, okay, DALDoc is a particular document format with links. It's native to TempleOS. And if you want to convert a DALDoc to a HTML, I added stuff. I added HTML chunks. Basically, I got tired of making it more and more general as I started modifying my HTML, customizing my HTML. I wanted more and more different things, and at that point, it was no longer possible to make a generic routine. So here's what I do. You need to take this, copy it into your home directory, and once you now you go home. Now you have your own 2 HTML. Now you can customize this all you like. And what I did is I made my own into I think I made cyan. Oh, as a matter of fact, I have my own. As a matter of fact, there it is. Okay, delete. Okay. As a matter of fact, here's my own 2 HTML. So I modified it. If you know HTML, you can modify your conversion. So it's it was getting too ugly trying to keep it generic. So I went ahead, I removed it out of the, if you're wondering why the kernel why it's changed size, I got rid of I got rid of some memory code, I got rid of the compiler, I got rid of an optimization. Normally you add optimizations, but there was kind of a, from the beginning I had a flexibility that made it doubly complicated, and I cleaned that up. And so now the compiler is slightly less optimal, but the code is much cleaner. And that's the priorities we have. So I've been improving the code quality. We don't, if there's an ugly optimization that makes the code ugly, we don't have that. That's not what we're about. So let's see what God says.